Hey guys, Mr. Mathwiz here with another video for today's lesson. Hope you're watching this. I hope you enjoy it. I know math can be a little bit boring sometimes, but if you're watching this, then that means hopefully you just want to learn your information a little bit better, right? That's what this is all about, trying to learn our content better, trying to practice it better. Maybe there's something in class you didn't quite catch and you want to hear it a second time. That's why I'm here. All right, so today's lesson was a short lesson, but it was an important lesson. We had some new vocabulary words. We did some practicing long division. So some real important stuff in today's lesson. Let's go ahead and get started by doing a quick summary of some long division and then going into the vocabulary words. So a lot of you struggled with long subtraction, so I know long division is something we need to look at. All right, so starting off, let's say you had a problem like 2 divided by 5. All right, I'm sorry, 2 over 5. You see that fraction? 2/5, right, is what you would call it? 2/5 or 2 over 5. Well, because of everything that we've done in class, you know by now that every fraction is also a division problem. So 2 over 5 is the same thing as 2 divided by 5. Remember when we said that that symbol, that division symbol, meant a fraction? Because they look a lot alike. It means a number over a number. So whenever you see a fraction, it means division. Or whenever you see division, it means a fraction. They're the same thing. All right, so now we need to solve 2 divided by 5. So we're going to use long division. We got our little division sign here. One number goes on the inside, one number goes on the outside. A lot of you guys, and we're going to have to watch out for this because a lot of you are trying to do this backwards. You assume, a lot of you assume that the bigger number is going to go on the inside. So you assume it's going to look like that. All right? That is not 2 divided by 5. That is 5 divided by 2. Whatever number is being divided is the one that goes on the inside. So 2 divided by 5 means there's 2 and 5 is dividing it. So 5 goes on the outside. 2 is being divided by 5. So this is how we would write that. Okay? So now we need to ask ourselves, how many times does 5 go into 2? Well, 5 is larger than 2, so it doesn't go into 2. So we end up with a 0 right there. So since 5 does not go into 2, 5 times 0 gives us 0. And we need to ask ourselves, well, what do we have left over? Well, we didn't take anything out, so we still have 2 left over. So right now, we're dealing with 0 and 2 remaining. But we're not going to use just remainders. We're doing long division, so we're going to get decimals. All right, so now we need to ask ourselves, what do we do next? Some of you remembered this, some of you did not. That's okay. The next thing we want to do is we want to put a decimal point here and put a 0 behind it. Now, why are we able to do that? We're able to do that because any number can be written as that same number with more zeros behind it as long as you have a decimal point, right? So the number 2 means the same thing as 2.0. And it would also mean the same thing as 2.00 or 2.000, right? You can keep on going. As long as the zeros come after the decimal point and there's no other numbers back there, they mean the same thing. Those zeros act as fillers. They just kind of fill this place value. They fill the empty space, okay? So I put 0.0. So now I can bring that 0 down. Whoop, I brought it down a little too far. Let's bring that 0 down. And we're going to bring it down to right here, turning that 2 into a 20. So now I want to know how many times does 5 go into 20? Well, we know it goes into 24 times. So is my answer to this problem 2 divided by 5 equals 4? No, because when I put that decimal here, I should also put a decimal right there. Do not forget that decimal or you'll get your answer wrong. All right? So 2 divided by 5 actually gives you 0.4. So 4 times 5. Now just to check my work, I do 4 times 5. That gives me 20. I subtract them and I have nothing left over. So I am done. 2 over 5 equals 0.4. And I'm done. All right? Not every fraction is going to look so nice and pretty. Okay? Sometimes you have things a little bit more complicated. Sometimes you'll have things that are a bit longer. Sometimes you'll have stuff that has 4 or 5 values. In the lesson, some of the problems we did in the lesson had multiple digits before it eventually stopped, but it did eventually stop. All right? And then there were some we did in class that didn't stop. So let's talk about some of those examples. So let's do another fraction. This time, instead of doing 2 over 5, let's do 2 over 3. I'm going to change colors. All right. 1 looks weird. Let's move that. All right. So this time I got 2 over 3. So remember 2 over 3 can also be written as 2 divided by 3. So we're going to do long division on 2 divided by 3. So there's my division. I'm going to put 2 on the inside, and it's being divided by 3. So 3 goes on the outside. Make sure you put those in the right places. All right, so how many times does 3 go into 2? Well, 3 is larger than 2, so it doesn't go into 2 at all. All right, so we got a 0 there. 3 times 0 is 0, which means when I subtract it, I still have 2 left over. We haven't done anything to that 2 yet. I'm going to add my decimal, add my 0, bring it down. So this looks a lot like the other problem so far. Now I need to know how many times 3 goes into 20. Now I'm going to go ahead, just so I don't forget, I'm going to put that decimal point up there now. All right? Because remember, whenever I add the decimal behind the 2 to make 2.0, I have to add the decimal up top. All right, so 3 goes into 20 how many times? This might take you a little bit of guesswork. You may have to try a couple things. But the answer there, it was 6. 6 times 3 gives you 18. Remember, if you go with something where the number is too big or too small, let's do an example of that, actually. Let's say I didn't know it was 6. Let's say I went with 5. 5 times 3 gives me 15. 20 minus 15 gives me 5. Well, 5 is bigger than 3. So that is not the closest one we can get. The goal is to get as close to the number as possible without going over. So we can get closer to 20 than 15 because 5 is larger than 3. If your answer when you subtract is ever larger than the number you're dividing it by, you didn't go far enough. All right, so we know it's not 5. We know the number is going to be bigger than 5. All right, let's say I decide to try 7. See what happens. 7 times 3 gives me 21. Well, now I have the problem where my answer is larger than the thing I was trying to reach. You don't want to go over 20 in this case. I want to get close to 20 without going over. So 7 is too large. So if 5 was too small and 7 was too large, the logical number now would be to go with 6. 6 times 3 gives me 18. When I subtract them, 20 minus 18 gives me 2. Good. 2 is less than 3, so I'm okay. Now I continue. Put a 0. Pull that 0 down. Right there. I need to figure out how many times does 3 go into 20. I'm having a little deja vu. Didn't we say 3 goes into 26 times? Let's see what happens. 6 times 3, 18. Great. Now I got 2. Make my 0. Pull it down. 20. How many times does 3 go into 20? Wait a second. I thought we already did this. Yeah, we've been doing it a couple times, right? So if we keep solving this problem, guess what's going to happen? We're going to keep putting 6s up there. We're going to keep getting 18s. And they're going to keep giving us 2s, which turn into 20s, which gives us more 18s. Oh, sorry. Which gives us more 2s, which turn into 20, which gives us more 18s. And I could literally spend the rest of my life solving this one problem. Oh, it just keeps going and going and going. And up here, I would just have more and more and more and more 6s. All right? And it would keep going on forever and ever and ever and ever and ever and ever and ever. All right, so even though mathematicians love math, we don't want to do one problem for the rest of our lives. So how do we show it? Well, the answer to this problem would be written as 0.6 with a bar over the 6. That bar signifies that it is a repeating number. A repeating number. So basically, oops, somebody's phone is ringing. Pause that. All right, I'm back. That was a wrong number. Sorry about that. All right, so what I was saying is that whenever you have a number that repeats itself over and over and over and over and over again, we put a bar over it. We only put the bar over the part that's repeating. That's important. You only put the bar over the part that's repeating, but you put the bar over the whole thing that repeats. So, in other words, if I had a number that was, oh, I made a lot of mess with that. Let's say I had a number that was 0.425, sloppy handwriting. And then it went 425, 425, and it just kept doing this over and over and over again. Well, I would write that as 0.425, and the line would go over the 4, the 2, and the 5. It has to go over the whole thing. That's what signifies the 4, the 2, and the 5 are all repeating together. If you only wrote 0.42 and put the line over the 5, that's a completely different number, right? Because this number represents that one up there, 0.425, 425, 425, 425, 425, forever and ever. This number would mean 0.425555555, right? So the bar goes over the whole part that's repeating. That's how you signify what the number is. All right, now to the vocabulary. So the vocabulary that we talked about in today's lesson was terminating versus non-terminating and repeating versus non-repeating. So we have terminating decimals that we talked about, and we have non-terminating decimals. Terminating decimals are decimals that actually come to an end. Comes to an end, right? Sometimes they can be pretty long. So in the example up at the top, we did 2 divided by 5, and we came out to 0.4. This is a terminating decimal, but it's also a really small one. Terminating decimals can get much larger than that. Sometimes you'll have stuff that has 5 or 6 decimals. You may have, 0.35789, and then it just stops there abruptly, right? If you're doing long division and you eventually get to a point where once you subtract it, you come out to 0, like we did right here, you're done, right? But sometimes it takes a few decimal points before we get to that part, all right? But if it comes to an end at all, if it comes to an end, we call it a terminating decimal. Non-terminating means that it never comes to an end. It never reaches its end. Goes on and on and on forever, all right? Now we had some other vocabulary words. We had repeating versus non-repeating. Repeating versus non-repeating decimals. So repeating means that a part of it just repeats, right? A part repeats with no end. Part repeats forever. You can put this in your own words if you want to. But yeah, it repeats and repeats and repeats. So this would look kind of like the 4255555, right? This would be an example of repeating. So with this one, those are both repeating. So is the 0.6 with the line over it, which we got from the 2/3, right? That's repeating. So it repeats and it repeats and repeats itself without end. Non-repeating means it does not repeat itself. Does not repeat, or at least does not repeat forever, right? Does not repeat forever. That's important because sometimes we'll have decimals that maybe repeat in a small piece, but that doesn't mean they repeat indefinitely. All right, so just about wrapping this up. Let me see if there's anything I want to say about that. Oh yeah, there was something I was going to say about that. So these sound like some of the definitions. They are different, okay? So here's the key thing I want you to take away from the definitions. Terminating means it does not end. Repeating repeats forever, which means it also does not end. So every repeating decimal is technically, I'm sorry, I said that wrong. Non-terminating never ends. So every repeating decimal is also technically a non-terminating decimal, all right? It repeats forever, never ends. So every repeating decimal is also a non-terminating decimal. But, just because something, it took a picture of me. Why am I, Samsung, what can I say? All right, sorry, getting distracted. My tablet just took a picture of me for no reason. All right, so just because something is non-terminating, just because something never ends, does not mean that it's repeating. Okay, you following me? If something is repeating, by its very nature, it never ends. So if it's 0.37, or I'm sorry, we'd only have 1 point. If it's 0.37, it'd be 0.37, 37, 37, 37, 37, 37, 37, 37, indefinitely, right? We would call that 0.37 repeating, or 0.37 with a line over it, right? That would be an example of a repeating decimal, and it would also be non-terminating. However, there are numbers that exist. Here's big brain time. It's going to take a picture of me again. All right. There are numbers that exist that go on forever but do not ever repeat. All right? There are numbers that go on forever and never repeat. One such number is my personal favorite, which we talked about at the very beginning of the year, pi. Pi is a number that never repeats, but it goes on forever. All right? So just because... So in other words, these definitions are different. They do not always have to be the same. So pi is a non-terminating number that is also non-repeating. All right? That was your big brain moment. All right. So we talked about long division. We did some examples of how it works. We talked about our new vocabulary words. In this lesson, there are lots of problems to practice some of this. So make sure you do that. Oh, I'm not done yet. I forgot about the last part. Oof. I spent too long talking about this. All right, let's talk about the very last part. Sorry, this video is a little bit long. All right. The last part of the lesson that we talked about before we all left, the last part of the lesson was talking about similarities in fractions. So let's see, we did 2 over 5 earlier. Let's do 2 over 5 again. We're adding negatives this time. So if I have negative 2 over 5, we know that this means negative 2 divided by 5. Well, when we did our long division, we discovered that 2 divided by 5 came out to 0.4, right? Now remember our division rules. This is going back to the previous lesson. Our division rules tell us that if you have a negative divided by a positive, it's always going to be a negative, okay? So negative 2 divided by 5 gives us negative, the same answer as before, 0.4, all right? Now, what if it's 2 over negative 5? Well, 2 over negative 5 means 2 divided by negative 5. So then we have to look at our rules. Well, our division rule told us that a positive divided by a negative is always going to be what? Think about it. Positive divided by a negative. Well, based on our rules, it's always going to be a negative, which means that this answer would also be 0.4, but with a negative in front of it. So we have 2 divided by negative 5 gives us negative 0.4. All right, well, what about if the negative is not on the 2 or the 5, but outside of the fraction? What if it's negative 2 over 5? Well, if it's negative 2 over 5, then what that means is that the entire problem is negative. It's negative, I'm going to put parentheses, 2 divided by 5, which means that we're going to treat the 2 divided by 5 normally, and then we're just going to put a negative in front of it. Well, what's 2 divided by 5? 2 divided by 5 is 0.4, and now we're bringing the negative in front of it. So look at that. All 3 of these problems gave us the same answer. All 3 of these problems gave us the same answer. What does that mean? That means that if your negative's on top of a fraction, on bottom of a fraction, or outside of a fraction, they all act the same. All 3 of those mean the same thing, and they are interchangeable, right? These are not the same as a negative over a negative, all right? Because what do you get when you get a negative divided by a negative? Well, our rule told us that a negative divided by a negative gives you a positive, right? So in this case, if we had negative 2 divided by negative 5, we would have a positive 0.04. So this is separate from those, all right? That's separate. But all 3 of these are the same. Whether the negative's on top, the negative's on bottom, or the negative is outside, all 3 of these fractions are going to give you the same answer. All right, so please, this video is a little bit long. Please do some of the problems in the lesson, particularly activity 2. It would be a great activity to work on and to check your answers, which are posted in Google Classroom. All right, I'll talk to you guys later. Have a great day. Bye.